We're picking up with example 5 out of Unit 5, Lesson 1 on designing a study. Example 5 is about identifying flaws in experiments. The directions say, identify any flaws in the design of the experiment and describe how they could be corrected. So the experiment is a research company wants to conduct a study to determine whether a new fishing reel is more effective than the old reel. The experimental procedure consists of using the new reel to catch fish in one lake and using the old reel to catch fish in another nearby lake that is randomly chosen. The results were that the company concludes that the new reel is twice as effective as the old reel. So there's one thing that sticks out to me right away that could be a problem with this, and hopefully it sticks out to you in the same way. And the flaw is that the two fishing reels were used in two different lakes. And it's entirely possible that one lake might have lots of fish and the other lake might not have very many fish, and maybe that's why they caught more fish in one lake than the other. If you want to do a good experiment, you need to compare things in the same environment. So the new reel and the old reel would need to both be used in the same lake in order to effectively compare their results. We have a check your progress for example 5. Go ahead and read through the experiment. Pause the video, pick your answer, and then we'll see the answer on the next slide. Okay, our answer here is B. The experiment was that the researcher wants to conduct a study to determine the effectiveness of a new golf ball. They get 50 players with different playing abilities and compare the scores. They conclude that the new ball is more effective. Well, if all the players have different abilities, it's really hard to compare it in a good way. You need to have people with the same skill level using the new ball. Example 6, another real-world problem. This one's about pets. It says a research company wants to test a new food for overweight cats that promotes weight loss. State the objective of the experiment, suggest the population, determine the experimental and control groups, and then describe a sample procedure for how they could conduct the experiment. So the objective of the study, they want to determine whether or not the overweight cats, if they're given a new weight loss food, if they will lose weight. The population could be all overweight cats. The experimental group could be a group of overweight cats that are given the food that will cause the weight loss. The control group would be a group that are given regular food. The way you could design the experiment, the sample procedure, the two groups of cats could be weighed at the start of the experiment, and then the experimental group could be given the new food, and the control group would be given the regular food. And then after a certain period of time, whatever the experiment picks, you would compare. You would weigh the two groups of cats again, and then compare them to see if there's any difference. And this, again, this is just surface level of statistics. It's just the basics. There's much more detailed ways of doing this, which you would learn about either later in this unit or in the actual statistics and probability course or the AP statistics course. But this is just the bare bones basics of how you design experiments and how you conduct experiments. We've got to check your progress for example 6. It says a research company wants to test a new de-icer for frozen lox. Determine the experiment and control groups and describe a sample procedure. So go ahead and read through the options, pick your answer, and we'll see the correct answer on the next slide. Okay, our answer here is choice A. The experimental group would be the group where the new de-icer is used. The control would be where a different de-icer is used. Then you compare the new de-icer and the old de-icer, the control de-icer, and then you see which one was more effective. That brings us to the end of Unit 5, Lesson 1 on designing a study.